Okay, everybody, let's try two division of monomial expressions, and we can see the difference about where you place the quotient depending on who is larger, the numerator or the denominator. So in my expression, I have a divided by a to the 8th. Now, I'm going to come out and say this right now. If you look in a math textbook or if you look at another website, they may explain the process we're about to go through differently. They may do more steps. My goal as your math instructor is to make this simple and easy and doable. So I'm trying to do this with the least amount of steps, the least amount of confusion. Okay? So we know division means you would subtract exponents. That's the rule. When you do a division of the same base, you subtract exponents. That's our rule. We know our base is the same because we have a letter A here and a letter A here. First thing I need to know is my exponents. Well, we know this A has an understood exponent of 1. We know this A has an exponent of 8. Visually speaking, we understand what this means. A to the first means there's one A in the numerator. A to the 8th means there's 8 A's in the denominator. So we obviously know there's more A's in the denominator. So when we do our rule and we get our quotient, it's going to go where? Very good. It's going to go in the denominator. So the rule says when we divide same base, we subtract exponents. We're subtracting 1 and 8, we get 7. Everybody agree with that? We get 7. Where do we put our A to the 7th? We put it where there were more A's. So think about this, ladies and gentlemen. If you have 1A and you take it away, it's gone. If you have 1A and you take it from 8 A's, you'll be left with 7 A's. So 1 and 8, if we subtract, makes 7, and we're putting our quotient in the denominator because that's where there were more A's. Now here's the problem. Can you write a fraction with leaving the numerator blank? Heck no. So because we're doing division, this numerator has to be the number 1, not a 0, the number 1. Again, why? If I wrote this out the long way, and I said, all right, there's 1A in the numerator, and there's 1, 2, 3, 4, 5, 6, 7, 8 A's in the denominator. We know from arithmetic, dividing the same number gets us a 1. So when we divide the same letter in algebra, our quotient is 1. So when I divide A by A, it gives me a 1. That's why we're putting a 1 in the numerator. If you count 1, 2, 3, 4, 5, 6, 7, there are 7 A's in the denominator. So again, what I'm trying to show you is in algebra, we could do a lot of work, but we don't need to if we think. So the rule is you're memorizing. When we divide, we subtract exponents. We put our answer, our quotient, where the bigger amount was. Okay, let's try one more. Here's my division. I want to take 25xy cubed z divided by 50x to the 4th y. Before I even start my problem of division, I got another problem to deal with. My problem is this negative sign. That is Ms. Black's pet peeve. Where does the negative belong? Does it belong to the numerator, the denominator, or both? We've already discussed this. Anytime you see a negative sign hanging in the middle of the fraction bar, it floats up to the numerator. So I'm going to do that first. Okay? So now I have negative 25 divided by 50. Okay, we know a negative divided by a positive is going to be a negative. We know that. Keep my negative in the numerator. 25 and 50 we can divide. What is their greatest common factor? What is the largest number I can divide them both by? That's right, 25. And I know 25 goes into 50 how many times? Twice. The question is, where do you put the 2? Does it go in the numerator or the denominator? The rule is when you divide, you put the quotient where the bigger term was. So 50 is bigger, so the 2 would go in the denominator. Think about it. 25 divided by 25 is 1. 50 divided by 25 is 2. Now we're going to take care of our variables. None of these variables are like terms. They're not identical, but they do have the same base. We could divide an x with an x and a y with a y and a z with a z. because the rule is when we divide variables, we subtract exponents. So here we go. I want to divide x with x to the 4th. So what are my exponents? There are 1 and a 4. If I take 1 and 4 and subtract it, I get 3. So where would I place my x cubed? Would I place it in the numerator or the denominator? Well, x to the 4th is the bigger, so that's where my x cubed would go, in the denominator. It should make sense. If I have an x up here and I take it away, it's gone. If I have 4 x's in the bottom, the denominator, and I take 1 away, I'm left with 3. All right, let's keep dividing. I see in the numerator I have a y cubed, and I see in the denominator I have a y. I have like bases. So the rule is when I divide the same base, I subtract my exponents. My exponents are 3 and 1. 3 take away 1 is 2. Where do I place it? Where are there more y's? The numerator or the denominator? Obviously in the numerator there are 3 y's. In the denominator there's only 1. So there's more y's here. So that is why our y squared goes in the numerator. If I take 1 from 3, I'm left with 2. If I take this 1 away, it is gone. Now, we got to be careful when we're doing division. I still have a variable z. Does it have anybody to divide with? No. So do you throw away the z and don't write it? No, you leave it alone and bring it for the ride. This is like saying z divided by 1, which is just itself z. So the z stays in the numerator. So my quotient is negative y squared z over 2x cubed. Or if I don't like my negative on the numerator, I could put it down to the side. Either way, that is your rule for dividing. You subtract your exponents and then you place your quotient wherever the bigger term was. All righty, we still got more division to come. See you then.